Leave the outer integral alone. I like to put a set of brackets. Let's find the antiderivative of this with respect to y. So what do we have? xy plus what? Y squared. And we're evaluating that. Now this is where things get a little weird. Y is the variable, right? So we're going to let y be first the lower limit of integration, which was 2x squared. And then we're going to let the upper limit of integration be x squared plus 1. We're going to figure all that out, and then we're going to finish out the outer integral. So this is the first time we've ever done this, right? We've never before had to plug in a function into our antiderivative. So this will be equal to -1 to 1 integral, and then bracket. I will have two things when I'm done that I have to subtract. Figure out what that is, dx. So let's plug in to this expression for y, x squared plus 1. Okay? So x times x squared plus 1, I'll just put that here, x times x squared plus 1. And then plus y squared, so plus x squared plus 1 squared. Everyone see that? Then redo this again, but this time replace y with 2x squared. So x times 2x squared plus, what's y squared going to be? Square this. Four x to the fourth. I'm going to clean this all up first before I integrate it. Integral -1 to 1. I'll just do a parenthesis now. I'm going to have distribute through x cubed plus x. Can we square this? Plus 1. That's squaring that. Okay, this right here is 2x cubed, but I'm subtracting it. And this is 4x to the fourth, but I'm subtracting it. That. Do we have any like terms? We do have some, right? Questions? All right, let's put them in descending order. X to the fourth, we have -3. X to the fourth. Took care of those. X cubes, -1, so -x cubed. Got those. X squareds, only one of them, right? And plus x plus 1. All right, so I've got everything taken care of there. That's trivial at this point? Is that trivial? Yes? ... So I'm not going to finish it. You know what to do now, right? All right. Okay, let's take a look visually at what we just did. You sure there aren't any questions? Comfortable with the antiderivative of that? I know my Cal 2 students would tell me, please give us like 100 of those on a test and we'd be happy, right? Just give us a bunch of those. So I'm assuming here you're happy to see that at that point. But you probably feel unsatisfied because I didn't give you like a nice numerical answer. There's the domain in two-dimensional space. There's that same domain laying on the ground in three-dimensional space. Here's the surface, which we said was a plane. Here's just the region there plugged in where it would hit the plane if you map those points up into the function. And that generates a solid if you look straight down. Let me pull all this junk out of here. It's kind of jaggedy. That's just because I have the computer not plotting a bunch of points. Damn it. There. We found the volume of that solid. Well, we didn't. We almost did. Okay? Whatever numerical answer you would have gotten for that represents the volume of that solid. All right, cool. Is this different? Yeah. But yeah, those aren't the same two curves. Okay. So let's just look at this one. So your function that you're going to integrate is x squared plus y squared, right? That's going to be your integrand. And now you want to look at the region bounded by these two curves. See, right now you know these are going to be type 1 because that's all we've talked about. But when you get to your homework in problems like 21 through 29, they don't tell you what type region it is. So you're going to have to determine that. And until I show you type 2, you still kind of don't know what I'm talking about. So just keep that in mind when I'm approaching this. I'm always looking at this as I don't know what type region that is until I draw it. So x squared, that's familiar. (2x). It's a linear function. Something like that. We all see the region? It's that little sliver, right? How do I know that 2x is above x squared? Yeah, I know, but I'm saying when I drew it, I put the red one up there. Like, why? How do I know the red one doesn't come out over here? Like, you could plot a couple of points just to verify. All right, that region is a little too small. I'm going to kind of make it bigger over here. I'm going to exaggerate it. My parabola is doing like this. And my line is doing something like this. And if I think that this region is going to be type 1, then I'm going to need to be able to draw a vertical double arrow like this and move it left and right and make sure that the red one is always the top and the blue one's always the bottom. And is that going to be the case? Yes? Okay, so what's the top function written as a function of x? G sub 2, right? And 2x. And then G sub 1 is the one on the bottom. And that's your x squared. What still remains to be found? The intersection, right? Now this one I think we can all agree we don't need to go find, right? 0? But we do need this one. So to find that, you set x squared equal to 2x, right? And what's your solutions? You get two of them, 0 and 2. 0 and 2. I'm not showing that, but that's what you would get. So this is 2. So as I slide this thing left and right, the x's are stuck between 0 and 2. The y's are stuck between two functions of x. It's type 1. We set up the integral, go to town. Yeah? All right, for this one, I'm just going to set the integral up. I don't think I'm actually going to do any of it. Unless you want me to. I'll take a vote. What's the bottom limit of integration here? It's g1, so x squared, and then 2x. And you can even put y equals if you want. Y equals x squared, y equals 2x, but I usually don't. The book doesn't either. What are we integrating? Yeah, that's our order. X squared plus y squared, and then dy dx. Okay? That's it. Integrate this with respect to y. Let's just talk about it. It would be x squared y, 1/3 y cubed. You'd go in, you'd replace y with those two things, figure that out algebraically, and then go back through, integrate that, plug in your x's, and be done. So dot, dot, dot. What's that? Dot, dot, yeah, on the test you just put dot, dot, dot. Yeah. All right, so then what is a type 2 region? A type 2 region helps you deal with regions that you have when the curves you're looking at are not functions of x. So this time, what we're going to have is we're going to have that our y value is trapped between two constants, and our x values are stuck between two functions of y. So it's basically a sideways picture of what we just did. You have your y's are stuck between two places. If you draw a horizontal double arrow, then your left x, right, your left x value is bounded by the red curve. Your right x value is bounded by the blue curve. And so the blue and the red functions are both functions of y. So we'll call this one h sub 1 of y and call this one h sub 2 of y. We just use h instead of g. And so what do you think the integral is going to be? Double integral. What do you think what's the order of integration going to have to be? It's going to be dx dy this time. You're going to have on the outside one the y's. So we use c and d so we don't confuse them with a and b. And then here it's going to be our, which one do you think happens first? H1, H1, and H2. So with G1 and G2, it was easy because you could say, you know, G2 on top, G1 on the bottom. This one, it's H2 is the right one, H1 is the left one. Or if you turn your head sideways, it's the same thing as a type 1. Understand? All right, and then in here is the f of xy. Now, there's something in this problem that kind of gives it away that this is going to be a type 2. What kind of gives it away?
Y squared.
That y squared. You see it in there? You see this right here? Y squared is equal to 2x plus 6. If you try and turn, well, let me go back. This right here, you could say is a function of x, right? Y equals some function of x. Y is x minus 1. This one, though, to turn it into a function of x, you'd have to solve for y, which means you'd need a plus or minus, right, when you take square root. And so you're actually going to have two functions there, and that's the problem. It would be easier to solve this for x, wouldn't it? And then this one would also be easy to solve for x. Okay. Let's see if we can draw this, though. Y equals x minus 1. That should be easy for all of us to draw, right? Y-intercept of -1 has a slope of 1. Looks like this. But how about this one? How are you going to draw this? It's a parabola, right? Sideways. So let's see how we could do that. Let's go ahead and try and solve this. Let's solve that for x. We get y squared minus 6 equals 2x, right? If we divide both sides by 2, we get 1/2 y squared minus 3 equals x, not 0. And just rewriting it in a different order. Now, in the back of your mind, you could do this. Just think about, what if it were switched? What if this were y and that were x? Then would you be comfortable graphing this? What is that? X squared parabola. Half parabola makes it wider, right? And then moving it what? Down 3? So this is the same idea except sideways. And so it's a parabola that opens up sideways, right? But it's wider, and it's, what's down 3 mean for us sideways? It means to left 3. Right, so remember, positive is that direction, so negative is this direction. Just like here, positive was up and negative was down. So it's the same idea, just this way. And then we draw it. Negative 3 is over here. And I don't know. They're going to hit, right, somewhere. Y'all good? Type 1? Type 1? Type 2. So let's look. If I try type 1, if I draw a double arrow right here, right, the blue function is on top of the red function, and that works. But as I move that over to the left, what happens eventually? How about when I get over here? Blue on top, blue on bottom. Same function. That's a problem. And that's why you can't do it as a type 1. Because this curve is the same as this curve, right? So technically, when I try and do the top curve minus the bottom curve, over here, I'm going to get 0. Something's going to go wrong there because it's the same function, same curve. So type 1 is no go. But if we do type 2, we draw these little arrows sideways, horizontally, then move that up and down through here. No matter how you do it, the blue one will always be the left bound. The right one will always be, the red one will always be the right bound, won't it? No matter what. So better suited for type 2. For sure. And because it's type 2, what I need to do is rewrite these curves as functions of y instead of x. So can you tell me what this blue curve is as a function of y? We got it and solved it for x, didn't we? That creates the function of y right there. This left side gets replaced with, what letter are we using? H. H sub what? 1 or 2? 2, 1. The one on the left is 1, right? Okay. So h sub 1 of y is what? 1/2 y squared minus 3. Yeah? Then this red one, which is our right bound, is our h sub 2 of y. And that is the line solved for x, which we hadn't done, had we? We hadn't solved this for x, but we could. Y plus 1. Y plus 1. Right? So take this. That's x equals y plus 1. That's how I got to this. That's an arrow. No questions? What else is still out here for me to resolve? Bounds on y. So we want to know where these hit each other still, right? But we want to know